Now let me talk about introduction part of the project. This UCS551 project gives us the chance to predict and apply skill in data analytics and representation by applying advanced instruments such as RapidMiner and Tableau to the student. RapidMiner is a data science leader platform offering the student the tools to explore data mining, machine learning, and predictive analytics. By using RapidMiner, students can learn how to clean and reprocess big datasets, develop and test predictive models, and apply techniques such as clustering, classification, and regression to gain meaningful insight. Meanwhile, Tableau serves as an extension of RapidMiner. It helps make raw and complex data more insightful and visual by using interactive dashboards and reports. With Tableau, students will gain the skill of creating visually interactive representations that communicate their research findings clearly and intuitively. The combination of the tools gives students a broad view of the data science. This means in-depth analytical ability must be developed along with the ability to effectively control data through visualization. Overall, this project not only improves technical skill but also develops critical thinking and problem-solving abilities. It exposes students to real-world industry applications across healthcare, finance, marketing, and operation. By the end of the project, we aim to gain the skill necessary to build a career in data science, business intelligence, and analytics, which is learning how to analyze, interpret, and present data in ways that support decision-making and organizational performance.
Next is case study background. This case study uses a Kaggle dataset titled Extrovert versus Introvert behavior data to explore behavioral and emotional differences between introvert and extrovert. The dataset includes 2,900 self-reported entries with features like social outing, communication method, emotional expression, and lifestyle choice. The goal is to apply data analytics to identify patterns that separate personality type. Also, using visualization and classification model, we examine traits such as emotional openness and social fatigue to better understand personality and improve teamwork, education, communication, and mental health strategies.
For this slide, let me explain the problem statement. As you can see on the screen, extrovert vs introvert behavior data aims to help determine whether a person's personality type can be accurately predicted using their behavior trait. In today's data-driven world, understanding personality type, especially introvert and extrovert, is very important. It can help improve communication, productivity, and engagement across many industries. We are using a dataset from Kaggle titled Extrovert versus Introvert Behavior Data, which provide rich data like communication on habits, emotional responses, and lifestyle behavior. However, even though the data is rich, it's not always clear which behavior traits are the most predictive or useful. That's a major challenge. There is also a growing need for reliable classification model that can separate introvert and extrovert. This helps in decision making for areas such as hiring, education, and target marketing. Using RapidMiner, we will address this by problem. First, cleaning and reprocess the dataset. Second, visualizing it to discover trend and correlation. And finally, applying machine learning model like KNN, knife Bayes, and apply model. Our goal is not only to build a correct model, but one that is explainable and practical in real-life situations. This will allow us to better understand personality characteristics and lead to more personalized human-based environment, especially in industry where communication and style really matter.
Our main objective is to determine whether a person's personality type can be accurately predicted using their behavioral traits. By using RapidMiner, we are able to first clean and preprocess the dataset by handling missing values, reducing sample size, setting attributes roles, and ensuring data consistency. Second, conduct predictive analysis using knife Bayes and KNN algorithm to classify individuals as introvert and extrovert based on their behavioral traits. So the third, to evaluate the performance of this analysis using accuracy, confusion matrix, and ROC curve to provide a comprehensive comparison of model effectiveness. And the last one, to present findings in a clear and visual format for easy interpretation by non-technical users.
Next is methodology. For the first one is business understanding. This space examines behavioral and psychological trend of extrovert and introvert people to support sound business decision. By studying traits like frequency of social interaction, emotional expression, decision making, and receptivity to experience, organization gains insight into personality role in behavior, and this is also can help in human resources, marketing, customer service, and organizational development. The data can be used to individualize communication, team setup, and employee engagement. The goal is to turn psychological data into practical strategies based on personality-based behavior. Next is data understanding. The dataset was collected from Kaggle and contained 2,900 raw entries about behavioral differences between extrovert and introvert individuals. Uploaded by Rakesh Kapilavai, it includes psychological and behavioral attributes to distinguish personality types. The dataset has numerical and categorical attributes such as time spent alone, stay fear, social event attendance, going outside, drained after socializing, friend cycle size, post frequency, and personality. It aims to show differences in communication, emotion, and social engagement with about 4% missing value in some key attributes. Next is data preparation. This dataset needs several data preparation steps to make it clean, consistent, and ready for accurate prediction. First, we use the read CSV operator to load the data, then select attribute to keep key features like time spent alone and personality. Also, we use filter example to remove missing value and replace the missing value with the average. We use sample stratified to reduce entries and also use the rename to change personality to behavior and set rules to label the target. This step help improve model performance and accuracy. Next is modeling. To measure dataset performance, we use KNN and nice Bayes operator to compare their classification accuracy. KNN classifies a new input based on the majority of its closest neighbor using distance, like Euclidean distance. It's easy to use but sensitive to feature scaling. Nice Bayes use Bayes' theorem and assume features are independent, making it fast and good for categorical data. Both algorithms are used to predict extrovert or introvert types, and their results are evaluated for accuracy and reliability. Next is evaluation. To check if our dataset results are accurate, we use the performance classification operator in RapidMiner, and it gives important value like accuracy, precision, and recall to evaluate the nice Bayes model. We also use the general performance operator to check if it's a classification or regression task. Hyperparameters like lab list correction and number of bins help improve the result. We also use accuracy and the confusion metric, which show true, false, positive, and negative to understand how well the model classifies extrovert and introvert. And for the last one is deployment. After completing all steps, we review the project outcome. If results do not match our original goal, we do a project retrospective to reflect on what went well, what needs improvement, and how to improve in the future. This helps the team learn from both success and challenges. A final report is also created to officially record the project result, including data mining, evaluation, lesson learned, and recommendation. A final presentation is used to share the findings and make the knowledge useful for others.
Let's go through some of the important data attributes we use in our analysis. First, we have time spent alone, which data type is real. This defines how many hours a person spends on their own. It helps to measure the urge to be alone, which varies between introvert and extrovert. For example, an individual might spend 4 hours alone while another spends 9. Next is that stage fear, which data type is nominal. This is a categorical variable showing whether someone experiences fear during public speaking. Introvert may experience more stage fear than extrovert. For example, an introvert might answer yes, while an introvert answer no. And then social event attendance, which data type is real. This indicates how many social events the person attends. Introvert typically attends more, while introvert attends fewer. For instance, one participant attends 4 events, while another attends 0. Now moving on to the next set of attributes, which is going outside, which data type is integer. This tells us how often someone goes outside or engages in outdoor activity, which measure in days per week. Extroverts usually go out more than introvert. For example, one person may go out 6 times a week while another goes 0. And then drain after socializing, which data type is nominal. This shows if someone feels tired after socializing. Introvert may feel drained while extrovert feel energized. For instance, an introvert may say yes, but an extrovert may say no. And then friend circle size, which data type is real. It represents the size of a person's social skill. Extroverts usually have a larger group, while introvert may have fewer but deeper connection. For example, one person might have 13 friends while another has none. Lastly, we have the remaining true attribute. Post frequency, its data type is integer. This represents how often a person posts on social media, which measure in posts per week. Extroverts usually post more often than introverts. For example, one person may post 5 times a week while another posts 0. And lastly, personality, which data type is nominal. This is the target variable. It classifies individuals as either extrovert or introvert based on their behavior. Extroverts are typically more social, while introverts are more reserved. For example, one individual is labeled extrovert, another introvert.
Now, I will present the result and discussion part. So for the first one, I will present the process, which is the purpose for each operator in the process in rapid manner. So firstly, we use read CSV operator. This operator is used to read data from a CSV file. It imports the data set into rapid manner so the data can be processed and analyzed. Next, we use select attribute operator. This operator selects specific column from the dataset that are relevant for analysis. Next, we use filter example operator. This operator filter the rows in the dataset based on a condition, such as removing rows which have missing value. We also use replace missing value operator. This operator fills in missing or empty values in the dataset using a method like replacing them with the average, maximum, or minimum. We also use rename operator. This operator allows you to rename columns or attribute in the dataset. Next, we also use sample stratify operator. This operator takes a smaller portion of the dataset but keep the same class balance. We also use set role operator. This operator sets the role of a column, usually by marking one of the column as the label and the others as input features. We also use net Bayes operator. This operator create a classification model using the net Bayes algorithm, which is based on probability. We also use KNN operator. This operator builds a model that makes prediction by looking at the k closest data point, which known as neighbors in the training set. We also use apply model. which is this operator applies the trained model to new or test data to make prediction. We also use performance model. This operator calculate performance metric like accuracy and correlation to evaluate the model result. And the second last is we use compare ROC operator. This operator shows and compare the ROC curve of different model to evaluate their performance. And lastly, we use cross validation operator. This operator split the data into several parts, which is called false, and test the model multiple times using different combination of training and testing data. That's all for this part. I will explain the next one. Okay, now I will explain the result in the rapid miner system. So before starting the process in the repository panel, we click the three line beside the import data and click create repository. And then in the alias column, we type group project group 1. Okay, click finish. Okay, and then next we retrieve the data set. So we will retrieve the data set using read CSV. So we type read CSV and drag it to the process panel. And then in the parameter panel, we click import configuration wizard and select our data set. Okay, so our data set is extrovert and introvert data set. Okay, click next, finish. Okay, link it to the result port and run the process. Okay, as you can see, this is our data. Okay, next, we will select all attribute except post frequency. Okay, so in the operator panel, we search select attribute, and then we drag it to the process panel. And then in the parameter panel, we change the attribute filter type to a subset. Okay, and then click select attribute, and then we select all attribute except for the post frequency. Okay, okay, click apply, and then run the process. And as you can see, all the attribute is in here except for the post frequency. Okay, and the next one, we will clean the data from missing value. So before that, in the result view, we will find which attribute that have missing value. So we have three attribute that have missing value, which is time spent alone, social event attendance, and friend circle size. Okay, and then now we clean the data. We will clean the data from missing value. So in the operator panel, we search filter example. Okay, filter example, and then we drag it to the process panel. And then in the parameter panel, we click add filter and click add entry because we have three attributes that have missing value. So first one is time spent alone, and then the second one social event attendance, and the third one is friend circle size. And then we select the parameter as is not missing for these three attribute, and then click OK, and then click apply. Okay, and in the result view, as you can see, for the three attribute, there is no missing value left. Okay, and the next one, we will replace the missing value with average score. So in the operator panel, we search replace missing value. Okay, and then we drag it to the process panel. And then in the parameter panel, at the attribute filter type, we choose subset and click select attribute, and then we select three attribute that have missing value just now, which is time spent alone, social event attendance, and friend circle size. Okay, and then click apply, and then we click edit list in the parameter panel, and then we select the three attributes just now, time spent alone, social event attendance, friend circle size, and replace it with average, and then click apply, click run. And in the result view, in statistic, we will see this three attribute has changed to average amount. And then the next one, we will reduce the data sample size. So we will reduce data sample size using sample stratified operator. So in the operator panel, we type sample stratified, okay, and then drag it to the process panel. And then in the parameter panel, change the sample to relative and sample size and the sample ratio to 0.7, and then we run the process. Okay, and then as you can see, the data set has become 1483 example, which means the data set has reduced by 70%. Okay, in the next one, we will rename the personality behavior. We will rename the personality to behavior. Okay, so how to rename? In the operator panel, we search rename. Okay, search rename. Drag it to the process panel. Okay, in the parameter panel, click edit list. Okay, old name is personality and new name is behavior. Okay, apply. So click run process, and as you can see here, the personality has changed to behavior. Okay, next one, we will set the behavior attribute to as target label. So in the operator panel, select search set role. Okay, set role, and okay, click here, drag to the process panel, and then in the parameter panel, edit list, and edit. Okay, select the behavior just now, and the target role is labeled. Okay, click apply and run the process. Okay, as you can see here, the behavior attribute has become label. So how to know? There is a green color in the column. Okay, next we will continue to the next part, which is we will use two techniques to evaluate the performance. So we will use two techniques, which is cross validation and compare ROC. Okay, so first we use cross validation first. So in the operator panel, we search cross validation. Okay, and then drag it to the process panel. Okay, double click the cross validation, and then you will see two parts of process panel, which is training and testing. And then we in cross validation, we use two machine learning algorithm, which is naive Bayes and KNN. So first we will use naive Bayes first. Okay, so in the operator panel, search naive Bayes and then drag it to the process panel, and then we also and then to measure the performance, which is accuracy and confusion metric of the data set, we need to use apply model operator and performance operator. So in the operator panel, we search apply model and then drag it to the process panel, testing panel, and then we search performance, and we drag it to the testing panel. Okay, so for the performance operator, as you can see in the parameter panel, we will click the accuracy because we want to see the result for accuracy, right? Okay, and then link the operator to the result port. Okay, link here, link also, link here. Okay, here also. Okay, and then we go back to the cross validation. Okay, as you can see, in the parameter panel, we will set the number of folds to 5, and then the sampling type is stratified. Okay, and then we link the process. We have three line to link. Okay, so and then we run the process. Okay. Okay, so as you can see the result here, this is the result for accuracy and this is the result for confusion metric, and I will explain it later. Okay, now we use second machine learning algorithm. Okay, click back the cross validation. Okay, and then in the operator panel, search KNN. drag it to the process panel. Okay, after drag it, the naive Bayes, we will disable the naive Bayes. Okay, so right click and enable operator. Okay, drag it down here, replace it with KNN, link the line. Okay, and then for this part, still the same. This part also cross validation also is the same, and just run the process. Okay, run the process. As you can see, this is the result for KNN accuracy, and this is the result for confusion metric, and I will explain it later. Okay, now we already done with the first technique. Okay, so the second technique we use compare ROC. So in the operator panel, we search compare ROC and drag to the process panel. But first, we must disable the cross validation. So right click, enable the operator. I brought it down here, replace with compare ROC. Okay, and then double click the compare ROC, and you will see a blank process panel. Okay, so what we should put here is the two machine learning that we used just now. So in the operator panel, search naive Bayes, drag it. Okay, search also KNN. Okay, drag it, link the process. Okay, link the process. Okay, go back to the process panel. Okay, so compare ROC, link the compare ROC to result port and run the process. Okay, as you can see, this is the result for the graph, for the ROC comparison graph, and I will explain it later. Okay, so that's all for result in the process rapid manner, and I will explain both comparison in the next part. Thank you. Now I will explain the compare two technique for producing the result. For the first analysis, I will present the analysis according to the cross-validation technique. So this analysis compare two machine learning model which are naive Bayes and KNN. Naive Bayes gave a higher accuracy which is 93.39% compared to KNN which had only 92.18% accuracy. This means naive Bayes made slightly more correct prediction and its output matched the actual result more consistently. The performance of both models was further evaluated using a confusion metric. The evaluation was based on four key components which are true positive TP, false positive FP, false negative Fn, and true negative Tn, assuming extrovert as the positive class and the introvert as the negative class. Although both models achieve the same number of true positive and false negative, which are 706 and 67, it indicating similar performance in correctly identifying extrovert individuals. Naive Bayes outperform KNN in classifying introvert. Naive Bayes recorded fewer false positives, which is 31, compared to KNN 49, meaning it made fewer mistakes by misclassifying introvert as extrovert. Additionally, Naive Bayes achieved a higher number of true negative, 679, than KNN 661, showing better accuracy in correctly identifying introvert. The reason naive Bayes likely perform better in accuracy and confusion metric is because it is a probabilistic model that works well even when the data set contain some overlapping data. It uses probabilities to predict classes and assume features are independent, which help reduce classification error in simpler dataset. In contrast, KNN make prediction based on distance and can be easily affected by irrelevant features or imbalanced data. This may explain why KNN produce slightly lower accuracy and more false positive in this case. In conclusion, naive Bayes provided better performance not just in numbers but also in decision quality. It made fewer incorrect prediction and handled both classes more consistently, making it the better model for this task. This all for this part. Let's go to the next part. For the last part, I will explain the analysis according to the AUC ROC curve technique. As you can see in the AUC ROC graph, as shown, the red line shows the ROC curve for K and N, and the blue line shows the ROC curve for naive Bayes. From the graph provided also, the K and N model curve rises sharply toward the top left corner, which suggests it performs strongly at lower threshold value, such as 0.3. This means the model is very confident in detecting extrovert early, even when the classification boundary is low. On the other hand, the Bayes curve is more gradual and stable, indicating that it performs more consistently across thresholds, including the commonly used default thresholds such as 0.5. Although the ROC graph shows overall model potential, it is the confusion matrix that reflects the actual classification performance. Therefore, while KNN may appear stronger in certain parts of the graph, net Bayes remain the more balanced model in real use. In conclusion, the AUC ROC graph is a helpful tool to compare model behavior, but it should be read together with the actual prediction result for real-world accuracy. KNN appears stronger in the early part of the ROC graph, but its higher false positive reduce its overall performance. Meanwhile, naive Bayes give more reliable and balanced prediction, making it a better choice for classifying extrovert versus introvert in this dataset. That's all for this part. Thank you.
Assalamualaikum, my name is Nur Inshira. So today I will be presenting about 4 graphs that have been produced using Tableau. So first, as you can see here, this is the front interface of our Tableau. So first we extract our file, our database file. Okay, there. And then we go to the sheet 1 that we want to create a graph. So the first graph I want to compare personality between friend circle size. So as for the first graph, I want to choose the bubble chart, and I want to compare with average. Okay, so the name of this bubble chart is personality versus friends circle size. So this bubble chart titled Personality versus Friend Circle Size highlights a general trend observed in the relationship between personality type and the size of an individual's social circle. The data from this chart shows that the extrovert personality has a higher number of friend circle size compared to introvert personality. Okay, the overall pattern of the bubble supports the idea that extrovert individuals who are naturally more outgoing and sociable tend to form and maintain larger and more diverse social networks. Meanwhile, introvert may prefer deeper, more meaningful relationships with fewer people, which reflects in their smaller friend circle size. So moving on to the second graph, which I want to compare personality. And also going outside. Okay, so for this part, I will choose the horizontal bar. So the title for the chart is Personality versus Going Outside. Also, I want to compare them with average number. So this horizontal bar chart titled Personality versus Going Outside shows the relationship between the type of personality and the average frequency of an individual going outside. The y-axis represents the type of personality, which are introvert and extrovert, while the x-axis represents the average frequency of the individuals going outside. The data from the chart shows that extrovert tends to go outside more with the average frequency of 4.6 days per week compared to the introverts that go outside with frequency of only 1.3 days per week on average. This chart highlights a clear behavioral difference between extrovert and introverts in terms of social activity and outdoor engagement. Understanding these patterns can be valuable for tailoring social programs, designing public space, or even planning group activities that consider varying comfort levels with outdoor interaction. It also reinforces the idea that personality traits can significantly influence lifestyle habits and daily routines. So move on to the third graph. We want to compare personality and time spent alone. So as for this graph, I will choose the bar chart. So also I want to compare with average. So the total for this bar chart is personality versus time spent alone. So this bar chart titled Personality versus Time Spent Alone shows the comparison between the extrovert and introvert on the average time spent alone. The data collected stated that introverts tend to spend more time alone, precisely 7 hours per day on average, while the extroverts spend only 2 hours of personal time per day on average. These findings highlight the significant impact personality traits can have on social behavior and daily routines. Understanding such differences is crucial not only in personal relationships but also in professional and educational environments where collaboration and independence are both valued. By recognizing this preference, individuals and organizations can foster environments that support the well-being and productivity of both introverts and extroverts. So, moving on to the last graph, which we want to compare personality and post frequency on social media. As for this part, I will use 3 map chart. So I will compare also with average. Okay, here. So the title for this graph is Personality versus Post Frequency. Okay, the 3-map chart titled Personality versus Post Frequency shows the comparison between introvert and extrovert regarding the average post frequency on social media in a week. The data indicates that the extrovert has a higher frequency of social media posts with the average of 5.6 times per week, while the introvert only posts with the average frequency of 1.4 times per week. This contrast in posting behavior reflects the broader differences in how extroverts and introverts engage with their social environment. While extroverts may use social media as a tool for frequent interaction and expression, introverts may prefer more reserved and selective engagement. These insights can be valuable for tailoring communication strategies, marketing approaches, or even developing social media platforms that cater to different personality types. So that's all from me. Thank you.
In conclusion, this project used data analytics to study introvert and extrovert behavior using the Kaggle dataset. By applying CRISPDM, RapidMiner, and Tableau, we cleaned data, built model, and created visualization. The result showed that nice players performed better than KNN. The project also shows how data science support understanding personality and improving communication.